Hello, welcome everyone. Welcome back to my channel. We are doing differentiation. We have already completed the theory on differentiation A level A1 and today we are doing A2. In A1, it's already algebraic function that's in your syllabus, whereas in A2, it's not only algebraic, it's exponential, logarithmic, trigonometric, inverse trigonometric functions as well. So today I'm taking example. I'm just giving you the information about the logarithmic, exponential and trigonometric functions. So let me see the differentiation of trigonometric functions. So if your function is sine x, then differentiation of sine x is cos x. If your function is cos x, then differentiation of it will be minus sine x. If your function is tan x, its differentiation is sec squared x. If your function is cosec x is nothing, it's just reciprocal of sine x. So either I can write 1 over sine x or 1 over sine x can be written as cos x. And the differentiation of cos x is minus cosec x cot x. If your function is sec x is nothing but it's a reciprocal of cos x. And differentiation of sec x is sec x tan x. And if your function is cot x is reciprocal of tangent, which is tan x. And differentiation of cot x is minus cosec squared x. So these are the differentiation of these trigonometric functions. We have exponential function. It's very easy. The differentiation of e to the power of x is e to the power of x. And differentiation of log base ax is 1 over x log a. So the first that I'm gonna do is product rule. In year 1, product rule is not in syllabus because ultimately we were studying only algebraic functions. So there's no point of using product rule because product rule is you can apply in algebra as well, but we can solve that algebra by multiplying and simplifying it. So it wasn't necessary there, but when you have two entirely different functions, in that case we do need it. Now take an example of this. We have ex times sine x. I can't multiply and simplify them any further, so I have to apply product rule, that means multiplication of two functions. The formula says dy over dx should be, let's say this be first function and this be second function. You can name any function as first or second. There is no order in this case. So differentiation of first function times second function plus differentiation of second function times first function. That means differentiation of first function, which is e to the power of x, will give me e to the power of x times writing second function as it is, which is sine x in this case. So I'll write sine x as it is, plus differentiation of second function, which is sine x, and differentiation of sine x is cos x, and writing first function as it is, which is e to the power of x. Now I can simplify it by taking out e to the power of x as common. Remaining is sine x plus cos x. And that's your answer. Let me give you one more example. Let's say I'm multiplying sine x times cos x. Well, this can be done by trigonometric identity as well, but here I'm using product rule. So I can name any function as first function and second function. So let's say this be first and this be second. So differentiation of first function times second function plus differentiation of second function times first function. So first we are finding the derivative of first function and multiplying it with the second function as it is, plus the derivative of second function and multiplying it with the first function. So differentiation of first function is cos x, and cos x will be written as it is. Now differentiation of second function, which is cos x, is minus sin x, and first function as it is, which is sin x. So we'll get cos squared x minus sin squared x. Either I can leave like this, and we know this is an identity for cos 2x. When I expand cos 2x, it's cos squared minus sin squared x. If you haven't done trigonometry, it's fine, but if you have done, you should be aware of this. So this can be written as cos 2x. And similarly, in the beginning itself, we can solve it by identity. Now, another rule is called quotient rule. A quotient rule is when your two different functions are in division. That means, say for example, we have e to the power of x over sin x. These are two entirely different functions, and how we can differentiate? See, the most common mistake is you differentiate them separately, like the numerator and denominator, so e to the power of x over cos x, and you'll get the answer. No, this is not correct. You have to use the quotient rule for this one, just like we have applied product rule. So in this case, you can't assume any function as first or second. It has to be precisely, your numerator has to be first function always, and denominator has to be a second function. Now the quotient rule says you have to differentiate first function, multiply the second function, minus differentiate second function multiplied first function. It's exactly like the product rule, but difference is there it was positive and we are doing negative here. In between this is negative sign, and there is a denominator as well, which is a square of second function. So now you can understand why it's very important to specifically make numerator first function and denominator second function. So if I'll apply this whole rule in e to the power of x over sin x, we'll get this first function. Differentiation of first function, which is e to the power of x, is just e to the power of x. And second function will be sin x minus differentiation of second function, and we know sin x is what? It's actually cos x. So this will become cos x and multiplied with e to the power of x over square of second function. Now I can take out e to the power of x as common. It's sin x minus cos x over sin squared x. And that's your final answer. Applying the same one in a different function, let's say cos x over, let me make sin x. Let me prove this. Though we know cos over sin is cot x, and it's actually minus cos x squared x. That's the differentiation. But let me do this with product rule. So cos x by sin x. So this is going to be the first function. This is going to be the second function. Applying same product rule. So differentiation of first function, which is cos x, that will give me minus sin x multiplied second function as it is, minus differentiation of the second function, which is cos x, multiplied first function as it is, over square of second function. So I can take out negative out as common. This will become sine squared x plus cos squared x over sine squared x. We know according to the trigonometric identity, sine squared x plus cos squared x is 1. So this is negative 1 over sine squared x, which is negative cos x squared x, which is same that I have given you. Let me take one more example. Let's say this be 10x over e to the power of x. So this will be first function and this will be second function. Same differentiation of first function 10x is x squared x times second function as it is minus second function differentiation of e to the power of x is e to the power of x. So e to the power of x times first function as it is. Again, I'm saying I haven't written e to the power of x as it is. The differentiation of e to the power of x is same over e to the power of x whole squared. From here, I can take out e to the power of x as common. This is x squared x minus 10x over e to the power of 2x. From here, I can cancel out 1 e to the power of x. So answer is x squared x minus 10x over e to the power of x. We can further simplify, but I think this is the most simplified one. I mean, if you want to split that into sine and cos, but I personally feel it's not necessary. So that will be a final answer. Now, let me move on to the chain rule. Chain rule is generally used when we can't directly differentiate any function, when we don't know the known differentiation. Like take an example, if it's e to the power of 4x, we have studied that e to the power of x is e to the power of x, but what if we have not just x but 4x? So in that case, we have to use chain rule. And we have to substitute, we have to assume something. Say for example, the chain rule says dy over dx can be written as dy over dt times dt over dx. So what's happening here? I can cancel out dt and dt. So now this can, again, if I cancel out dt dt, it will again become dy over dx. So that's a way of writing dy over dx, and that's called chain rule. So for applying chain rule, we have to assume something as t, because e to the power of 4x, we can't differentiate it directly. We don't have any formula. But if we try to convert that into a given formula, the known formula, and by that, I mean, how we can do that? If I equate 4x to t, if I assume that, let's say, t is equals to 4x. So in that case, your t, this is what? Y, right? So when I have assumed t is equals to 4x, then y will become e to the power of t. And this is the function that we know. We know that e to the power of x or e to the power of t or e to the power of y, I mean, doesn't matter what variables up there, we know the differentiation of it. And that's how we have converted the given function into a known function. That's called known function. That means we know the differentiation of e to the power of x, or in this case e to the power of t. So that's why I have assumed t as 4x. This, we are done with it. Now we have to apply this in our chain rule formula. The chain rule formula says dy over dx is equals to dy over dt times dt over dx. These two functions are important. First says dy over dt, that means differentiation of y with respect to t. So where is y and t? This one. So if y is equals to e to the power of t, then dy over dt will be e to the power of t. We just studied, that if y is equals to e to the power of x, its differentiation will be with respect to x is e to the power of x. Similarly, if y is e to the power of t, so differentiation of y with respect to t will become e to the power of t. Now, we are done with finding dy over dt. Focus on dt over dx. So now we have to focus on this. We know t is equals to 4x. So dt over dx will be, now what we are doing, we are differentiating t with respect to x. So dt over dx will be, that means differentiation of 4x is just 4. And now substitute this in our formula. So this is our formula. dy over dx is dy over dt times dt over dx. So dy over dt is what? E to the power of t. We have just calculated. And dt over dx we have calculated as 4. So that's dy over dx. But obviously, we can't leave our answer in terms of t. It has to be in x. So coming back to that one where we have assumed our function and it was t is equals to 4x. That means I need to replace t again with x, which is e to the power of 4x, and that's your answer. Now let's say another example, which is e to the power of x squared. Y is equals to, then find dy over dx. Again, I can say that there is no direct formula which will give me the answer for e to the power of x squared, and nor I can apply any product rule or quotient rule. So obviously it's going to be a chain rule. I have to assume, let's say t is equals to x squared, because after assuming x squared as t, I can get a known function. So y will become e to the power of t. And yes, we can easily differentiate e to the power of t, as well as we can differentiate x squared as well. Applying chain rule, dy over dx can be written as dy over dt times dt over dx. Y is e to the power of t. So differentiation of y with respect to t is e to the power of t. And if t is x squared, then differentiation of this t with respect to x will give me 2x. Now, all we need to do is substitute at the very end, that means in this given formula. So dy over dx will become finally, dy over dt is e to the power of t, and dt over dx is 2x, e to the power of t. And finally, at the very end, we have to replace t with the one that we have assumed, that is x squared. So final answer is e to the power of x squared times 2x. And this is how we can differentiate such functions. So this whole video was just for the basic theory of this. Obviously, we haven't done too many questions on it. It was just a basic introduction so that you get to know what is product rule, quotient rule, or what is chain rule. Okay, so if you have any doubt, you can just comment down in comment section. I'll definitely answer you, or if I feel I can make a video on it as well, or if you're looking for free worksheets, for few theory worksheets or free like the question worksheets, just visit our website, which is exacademy.com. And also, if you're looking for one-on-one live online classes for A levels, they are starting at just £8 per hour, and we provide classes for maths, physics, for biology, for economics, and so on. So we provide classes for any number of subjects. So all you need to do is just book a free trial and email us at exactacademy@gmail.com. So that's it for today. Bye everyone. Take care.